Good morning, everyone. Graphing quadratics is what is on our list for today for notes. We are going to sort of simplify this more than we might do if we were in the classroom, but obviously we are not. So a couple rules. Take a deep breath. When you first see this for the first time, my students tend to feel very overwhelmed when they first see it. And then by the end, they're like, what was I even concerned about? The biggest thing today is that just everything is new. This is going to be information that we haven't seen, we haven't talked about. So it's going to feel a little bit like what the heck is going on. But by the time it all comes together in the end, it's super easy to do. It's the easiest way to graph quadratics. So don't stress. You might have to sort of let the notes process and watch through an example before you really sort of get the big picture of what's going on. So if you haven't already, right, I had the template that you could use to print off some graphs if you have a printer. If you don't have a printer, maybe just pause this video and take some time to draw some quick 10 by 10 grids so that you have something you could graph on. Otherwise, you can just pause when we get to it and draw it in your notes and then press play when you're caught up and ready to go. Okay, so a couple things that we want to know about graphing quadratics. Just like when we are graphing lines, we have formulas or formats that they come in. So one format is y equals a times x minus h squared plus k. Okay, we can tell by looking at this that this is going to be a quadratic because it has an exponent of 2, right? When we have a degree of 2, an exponent of 2, we know that we are then dealing with quadratics. Whenever we are dealing with quadratics, we know what they will look like. Just like anytime we're dealing with a linear function, we know that it will be a line. Anytime that we are dealing with a quadratic or a degree of 2, we know that quadratics will always graph and be what we call a parabola. So it kind of looks like parabola. Okay, and a parabola is a U-shaped graph. So you've seen these graphs when we were using Desmos to graph quadratics before spring break, right? And we were looking at those x-intercepts. But this is always the shape that the graph will make. Okay, so it'll always be a parabola. It will always be a U shape. Now, there are a couple things then that we can determine about the parabola based on the formula. Just like when we have y equals mx plus b, we can find m, which we know is our slope, and it's going to tell us how steep it is. And b is our y-intercept, which is going to tell us where it crosses the y-axis. We have those similar types of things here. So a, this number in front of the parentheses, is going to tell us if the parabola opens up and it looks like a U, or if it opens down and it looks like a hill. Okay, if A is positive, so anything greater than 0, if it's a positive number, it's going to open up. If A is negative, it's going to open down. So anything greater than 0 is a positive number, which will make it open up. If anything is less than 0, which is a negative number, it's going to make it open down. And we are going to focus on two very specific situations. So the only options we're going to see today is where A is positive 1 or where A is negative 1. Those are the only options that we will see for A. Okay, we then have our values H and K. Okay, these values here are going to make up what we call our vertex. Okay, our vertex is our starting point of the parabola. And now it's a little bit different, right? Because just like a line, it goes on for forever. But when I say starting point, it's sort of like that y-intercept. It's that first point we need to graph to sort of get the bigger picture. So this vertex is directly in the middle of the parabola. Okay, it's going to be the point either at the top of the hill or the point at the bottom of the U shape. Okay, the very top or the very bottom. It's going to be our high point or our low point. Okay, and the vertex is always made by doing H, comma, K. Okay, so we're putting our K value for our Y value, and our H is for our X value. Now, one thing we have to keep in mind here, right, we've talked about this before with other formulas. Anytime that there is a subtraction in the formula, right, subtraction we can read as a negative, as subtraction, or as the opposite, right? This tells us to take the opposite of h. So we need to use the opposite sign of h. If you're kind of like, what the heck? When we go through examples here, you'll sort of see what I mean. Okay, then there's one more thing that we can tell about a parabola from its formula, which is the axis of symmetry. Now, you actually learned about what an axis of symmetry was in like 3rd or 4th grade. You might not remember, okay, but an axis of symmetry is a line that cuts something in half. Okay, so remember, like you'd be given a picture of a square in elementary school. Okay, that's a terrible square. It's kind of a rectangle, but whatever. And your teacher would say, draw a line that cuts it directly in half. Okay, this line right here is an axis of symmetry. If we were to fold this square in half, it would match its opposite side. So a parabola has that exact same feature, right? If I were to draw a line right here, it would cut that parabola in half. Now, a vertical line, if we go back to our graphing unit, is an x equals line. So we know our axis of symmetry is going to be x equals, and x is going to equal the x value from our ordered pair. So x equals h. And here's where I just need you to take a deep breath because you're kind of like, what is going on? Just take a deep breath. We're going to put it all together in some examples, and it'll start to make some more sense, okay? So let's say I give you the function y equals x minus 2 squared plus 3. Okay, so there are 3 numbers that are going to be important in this function. Okay, the 3 numbers that come into play are our a value, our h value, and our k value. So if we can identify what those values are, it's going to answer all of these other questions for us. Okay, so remember, a is what's sitting directly in front of the parentheses, right? It's in front of the parentheses. We don't see anything here, right? So there's really a positive 1 there. So a is equal to 1. H is what's sitting with the x inside the parentheses. And remember, we said we had to take the opposite sign of it. Okay, so the opposite sign of -2 is a positive 2. Now, we do not want to take the opposite sign of k. That stays the same. Okay, so k is going to stay the same, so k is going to equal 3. So a is 1, h is 2, k is 3. So knowing that information, okay, a is positive 1. So if a is positive 1, that tells us that we are going to get a parabola that opens up. Okay, we then know that our vertex should be h comma k. So our vertex for this parabola is going to be 2 comma 3. Our axis of symmetry, okay, is going to equal x equals h. So our axis, we have to have that x equals there because it's a line. So we need that equal sign. It's an equation. Okay, x equals h, and h is 2. So we know that this is a parabola that opens up, that has a vertex of 2 comma 3, and that will be chopped in half at the line x equals 2. Okay, so at this point, we're just working on identifying that important information, and then we'll put it all together in a graph here in a minute. So let's look at another one. Let's say I have y equals negative x plus 5 squared minus 2. Okay, so there's 3 letters, again, that I can identify. I need to find A, H, and K, because those are going to give me all the important pieces. Okay, so A is what is in front of the parentheses. I see a negative sign, right? There's really a 1 attached to it, so it's -1. Make sure you write that 1. Don't just say the number is negative. right? That's not the value, that's just a sign. So you have to have that 1 with it. Okay, H, this looks like a positive 5, but we said we would take the opposite sign. So that's really going to be a negative 5. Our K is negative 2. We do not change the sign there. So this tells us that we have a parabola that is going to open down. Okay, so it opens down because A is negative, and a negative A means it opens down. Our vertex, which is H comma K, is going to be negative 5, comma, negative 2. And then our axis of symmetry is going to be X equals H. So in this case, X equals negative 5. Okay, when you feel comfortable with finding those 3 things, then we're pretty good to go. Okay, and then at that point, we can start to put things together on a graph. So let's then talk about what we need to know to get this onto the coordinate plane. And the main thing that we really need to know is we need to understand the basic rules of graphing the quadratic y equals x squared. Okay, so you have to think way, way, way back when. Okay, but way, way, way back when we said, what happens if we don't know how to graph something? Okay, this was a really important piece and I brought it up a couple times, but if we don't know how to graph something, we can always make a table and figure out what it looks like. Okay, so if there's any point that you're reading something, you're like, I have no idea how to graph that thing, right? We can make a table and we can plug in some x values and find some y values. It works for any function. Okay, so we could start plugging in any random numbers that we wanted to plug in. Okay, but I'm gonna give you a suggestion. Okay, and since we know that it's this U shape and we know we have this axis of symmetry, I'm gonna sort of give some points on each side. And because this is a U shape, it does take us a couple more points to actually get that picture. So I'm gonna pick 5 points and I'm gonna pick -2, -1, 0, 1, and 2. I'm picking those points because they're small, they're simple, but I'm also picking some positive and negatives because I've done this before. If you were guessing and you were plotting points, you would eventually figure out that you need to pick more. I'm just helping narrow it down for you. Okay, and then just like we would do with any problem, we would plug this in for the x value. So instead of saying x squared, I'll say -2 squared. But now remember, if you're using a calculator, that has to go in parentheses. Okay, so -2 squared is 4. Then I'll plug in -1. -1 squared is 1. Plug in 0. 0 squared is 0. Plug in 1. 1 squared is 1. And 2 squared is 4. Now, you'll notice when we look at this graph table, when we look at this table, these numbers match and these numbers match. That is not a coincidence. Okay, that happens because it's symmetric. So whatever we see above, we should also see below. Okay, this tells us, okay, this motion of plotting these points. If we were to plot these points, right, I would plot the point 0, 0. And then I would also plot a point that goes right 1, because this is +1, and up 1, because this is +1. All right, I'd go right 1 and I would go up 1. Okay, so I'm just gonna quickly plot these points. You don't necessarily need it, but I want you to sort of see what happens. Okay, so if I have 0, 0, 1, 1, 2, 4, -1, 1, -2, 4, right? Here's my U shape. So I'm connecting them like a U with arrows saying that it continues to go up for forever. Because our A values are only going to be 1 or -1 today, it means we are going to see the exact same duplicated shape. Okay, it won't look any bigger, it won't look any skinnier, okay, so it won't come out wider or be more squeezed. It's just gonna be sitting in a different place in the coordinate plane, which means that pattern of going over 1 and up 1 is going to be consistent with every problem that we see. Okay, so let's say we want to graph y equals x plus 2 squared minus 1. To graph this, the first thing we are going to want to do is identify A, H, and K. So we already were practicing this, right? A is going to equal 1. H has to be the opposite sign, so that's going to be -2. K also has to stay the same, so it is going to be -1, right? A and K stay the same. H is the one that changes. Okay, this tells us that we want a parabola that opens up, right? A is telling us its direction. H and K are telling us the vertex. So on our coordinate plane, so if you need to pause right now and draw a graph, go ahead and do that. Okay, so on our plane, we are going to plot the point -2, -1. That's going to be the same as this point right here that's in the center of our parabola. It's our low point, it's our minimum. And then we are going to follow the exact same pattern from our table before. We are then going to go from this over 1, up 1. So we want to go right 1, up 1. Because every quadratic that has an A of 1 or -1 follows the same pattern. Okay, then again, from our vertex, not from the second point we made, but from our vertex, we are now going to go right 2, up 4. Okay, and I want to duplicate that exact same thing on the other side of my vertex. So now I'm going to go left 1, up 1, right? So my table here, I'm going to go left 1, up 1. So I'm going to go left 1, up 1. Okay, and then I'm going to go left 2, up 4. So now, again, from my vertex, I'm going to go left 2, up 4. Okay, and it's okay if you're like, what the heck? That's usually where my students feel at this point, but they're like, okay, at least see what she said, but I couldn't do that on my own. Okay. We're gonna practice another one. So again, draw a 10 by 10 grid if you need to. And if you say, okay, well, Mrs. McKinney, where did the axis of symmetry go? Right, the axis of symmetry up here was really x equals -2. We don't have to draw it, but it is this line right here, right? That chops that in half. That's what that says. That's the line that will chop that in half. Okay, so let's look at y equals x minus 3 squared plus 2. Okay, so this tells us A is 1. H is 3, K is 2. The cat's been walking all over my desk and I have fur everywhere. Okay, so we're gonna say that our starting point is our vertex of 3, 2. And because A is positive, we know this is going to open up. So I'm going to plot the point 3, 2, right? An ordered pair is always right and left and then up and down. So right 3, up 2. And then I'm going to follow my exact same pattern. I'm going to go over 1, up 1. And I'm going to do the same thing on the other side because it's symmetric. And I'm going to go over 2, up 4. Now, if you're like, Mrs. McKinney, how am I going to remember those numbers? Well, A, you get to use your notes because we're doing e-learning. But B, right, it comes from the fact that it's a number squared. So if I was going to go over 3, I would need to go up 9 because 3 squared is 9. If I went over 4, I would need to go up 16 because 4 squared is 16, right? So I'm just following the pattern of a number squared. So however many I go right, I'm going to square that number, and that's how many I'm going to go up. Now, one of the things that you need to be able to do is identify some other points on the parabola. So for example, if we were to name this point, right, this is the ordered pair 1, 6. We would say that's symmetric to 1, 6 because it's the point it would fold on top of, right? I wish you could see my hands. It's kind of hard here. to show you, but if I were to fold this on top of itself, this dot would close on top of the other dot. And so this point right here of 5, 6 is symmetric to it. Okay, we could also say that this point here, 2, 3, would be symmetric to 4, 3. So if I asked you to name a point and a symmetric point, you could either name these two as a pair or these two as a pair. There is not a right or wrong answer. It doesn't matter which one you put first or second. You would just need to keep the correct pairing together. Okay. Let's do y equals negative x minus 5 plus 3. Okay, so if we pick this, we're going to find our a, h, and k first. So our a is negative 1. Our h is positive 5. And our k is positive 3. Okay, so now we're going to find our starting point. Our vertex is 5, 3. And I know that this is a parabola that's now going to open down. So instead of this opening up like a bowl, right, it's going to go down like a hill. So I'm going to plot my point 5, 3. But now instead of going over 1, up 1, right, instead of going over 1, up 1, I want to go over 1, down 1. And then over 2, down 4. Okay, so all I did was instead of going up when I wrote the word up, I'm now going down because I wrote the word down. If I wanted to name a point and a symmetric point, I could then name, let's see, 4, 2 is symmetric to 6, 2. Or maybe instead I would want to pick 3, negative 1, and that would be symmetric to 7, negative 1. Okay, so you have a Canvas check to do to go through. It's fill in the blank. Just pay attention to the fact of don't type in any spaces and leave everything as lowercase. So like when you're typing the direction of up or down, just leave it all lowercase. So no spaces, leave everything lowercase. And it should grade it right the first time. If for some reason you think that something is wrong or you accidentally type something funny, send me an email in Canvas and I'll go through. I tried to think of weird options, but sometimes I mess up. So send me an email in Canvas and I will go through and check it. Have a great day, class.